no further ado, I'd like to introduce the first speaker, Marc Fielding. Marc and I first met when I placed him in a short-term contract at TransferWise. Marc, correct me if I'm wrong, this was a Node.js contract position. So you were working on a third-party integration, which was done via REST API using Node, Docker, Kubernetes, AWS. So there was a pre-existing solution which was using AWS Lambdas in native JS. They wanted that to be ported to a Node service. So Marc, dare I remind you, 25 odd years of experience in software engineering. Anything else that you'd like to add in as an introduction to yourself?
Hi Tom, yeah, thanks a lot. Yeah, so I'll probably just step over to I'll share my screen and step over because there's a bit of background going with it. Okay, yeah, so my name is Marc Fielding. I am currently Chief Tea Officer to the High Street. I had the stupid idea a couple of years ago for a startup. We launched this year. Background is 20 years in technology. Thanks, Tom. Starting Clipper 5.2, moving on to .NET, PHP, and then finally JavaScript, with a particular leading recently in AWS, specifically in Serverless. Up until kind of the beginning of this year, or sort of first part of this year, I was contracted as an AWS consultant. I've helped startups launch and actually realize millions of funding, as well as work within large corporate teams, sort of showing them how to use serverless technologies. To the High Street is a crazy idea where we index all the local goods from shops, your high street stores, and we deliver to people's house within an hour. The idea is that if you search for AAA batteries on Google, what you typically find is Argos and Amazon, when that's not really what you're looking for. What you're looking for is your little corner shops and that kind of thing. Unfortunately, we didn't see COVID coming, so we launched at a time when all the shops had shut. So it's been a little bit of a slow start. We're also working in technology as well as serverless, or their APIs are serverless. We also work with computer vision technologies. So within the next couple of months, we'll probably have the world's largest CV database, being able to recognize not only a tin can, but a can of Dr. Pepper, a can of Coke, a can of Lil, and tell you exactly where to buy it. And there's all kinds of stuff that we do, which I'll explain a little bit more in the presentation on those kind of services. So what we're going to be going through today is why would you choose serverless? For those of you that aren't already in the cloud, we'd like to talk a little bit about how not to go into the cloud or into AWS or whoever you're looking into. Our approach to the way that we solved some of the problems as a development team. This is going to be a bit of a deep dive. There's going to be a demo there where I'll actually show you how we've structured some of our Lambda code, why we've structured it like that, and how we've solved some of the common problems that development teams encounter when they first start looking at Lambda or cloud functions, because it is a bit of a head spinner when you first start looking at it. Choosing a cloud provider, although I'm an AWS guy primarily, we do use some Google Cloud. We're even going to start using some Azure for different reasons. Scaling cold starts, this gets talked about a lot, but I'd like to give my view. Cloud managed services, that's a bit about the kind of things like Elasticsearch, AWS offer their offering, and maybe why you might want to consider other things. Compliance, things like GDPR, and then obviously we'll move on to some questions. So first one, why would you want to go serverless? Well, obviously the number one thing is on demand. If you're just talking about APIs, it's absolutely perfect for startups like us, but it's also perfect for large businesses. I mean, if you've got typically a server sitting in a data center where you've got, say, an API that serves metrics or just anything that's not constantly processing, but it just needs to be there and alive anyway, that's where your Lambda functions fit in. Also reduce team size. If you've got a Lambda, you don't really need your DevOps people quite so much. You don't really need, depending on what managed services you're using, you don't need to hire your DBAs. Sorry if there's any DBAs watching, by the way, but it does make the teams an awful lot leaner. Without most of our team are Node developers. We have, like myself, who's an AWS specialist. Aside from that, we hire good Node guys, and that's it. And obviously, you can scale up very quickly. If you suddenly have a microservice that becomes very popular, Lambda will scale with you. But there are some facets to that where there is a point where Lambda becomes unsuitable, which again we'll talk about in a while. If you're not already in the cloud, there are some considerations that you'd want to think about. So number one is, what sort of workloads are you running? Now, this is where I was talking about before. If you're running, I don't know, say image processing, which we do a lot of, where you're taking a video and you're cutting it into frames, and then you're doing things with those frames, resizing them, and you've got these lambdas that are running maybe 5 minutes at a time, 6 minutes at a time, 7 minutes at a time. That may not be the best way to run that workload. So choose the technologies carefully. You want to, if where possible, for things like APIs or short running tasks, or then serverless technologies are definitely going to save you money. If you've already got servers where whoever they are, if it's a server in a rack somewhere, and you want to just move all those servers onto EC2, it will cost you a lot more than it costs you now. To give you an idea, this is just something. Can I move this up? Yes, I can. So this is just a price comparison that I pulled off Google. Now this is comparing EC2 costs to rapid switch, and it's very easy to see the instance sizing. Sorry, I'll get rid of this. The instance sizing here, there is quite a big difference in it. So if you're just thinking we're going to go on to EC2 and it's going to save us money, it's not. It will cost you an awful lot more. And that's something to be aware of. And also, where this is about, where we're talking about profiling and workloads, what are you actually going to be doing? What are the benefits? And then have a look at the prices. Also, when you go and see a cloud provider, and I'll tell this story, but I will leave them nameless. I work for a large chain, a large hotel chain, and we went down to a couple of cloud providers, and they said, "Oh yeah, we can do this. This is what you want to use," and they threw every managed service that's possible so that it met our specifications. The simple fact is that they knew full well that when you hook into all these managed services, migrating away from that particular cloud becomes extremely expensive, because you have to rewrite an awful lot of code, and they know that. So when you do move into the cloud, make sure that you don't overuse managed services just because they're there. Even if you just come in, all your Lambda functions, that's great. I'll show you how you can move between clouds with Lambda. But if you're using managed services like RDS or things like Cognito, or any of the things that are kind of out of the box managed, ask yourself, do you actually really need to use them? Because if there is another way of doing it, you do kind of leave yourself more options in the long run. Right, to our approach, and I'll show you some code in a minute for this. We write all of our code for the cloud and not the cloud provider. What that means is that we have very, very limited provider-specific code. So in our case, we're on AWS. The way that we start is actually by writing Swagger. So we don't even write, we use serverless, but we don't write serverless definitions. What we do is we write Swagger definitions, and we have code that translates that into our provider definitions. So that gives us a great deal of freedom. Whereas if Google suddenly said to us, look, we're going to do you a great deal on cloud functions, and we thought it was a good idea, we can pretty much redeploy all of our APIs to Google Cloud within a couple of hours, with zero downtime. So that's a very, very good way of doing it, especially because obviously the cloud market is so competitive at the moment, that they are very much vying for business. Understand the challenges of the team. So if you sit down a guy that's an Express guy or a Node developer, and you go, you're doing the AWS Lambda now, his head is potentially going to explode because the documentation isn't fantastic. I mean, it is essentially just a Node app still, if you're talking about JavaScript, where you've got API gateway replaces Express, and then you've got your handlers, which is a typical Node handler. But there are some facets to that. So you need to really kind of plan for it, make sure you've got an understanding how Lambda works, and make sure you understand the technologies and how they integrate with each other. With all of our services, they are all in exactly the same format. It's very easy when you move on to, cloud or start new cloud projects, because everyone has either had different training or read the AWS manuals in different ways or Google Cloud's manuals in different ways. You can end up with one API that looks like one way of doing it and another API that looks completely different. That seriously reduces your ability to utilize your developers. So if a team's running behind, you can't then just move one developer to another team quite easily. And you can't just sit down and go, oh, look, that's exactly the same as what I was working on. So one of the things that we did right from the beginning is that every API without fail uses the same system, uses the same format, the same testing methodologies, and now all of our developers can work on anything. The other thing is they're not just cloud functions. Although I said don't run long-running tasks on Lambda, bear in mind actually what you're buying is a teeny tiny VM that executes and kind of hangs around for a bit and then disappears. The facets of that is that you have temporary storage, so if you need to download something, you can use it, and some kind of persistence. Now, the reason I mention that is because if you've got a container that hasn't been disposed of, you've got to remember to remove the files from the storage. So don't just think of them as functions. There are other things that you can use cloud functions or use these lambdas and cloud functions for. The other thing that we're really into, just to show you briefly, we're moving all of our hosting off EC2 onto serverless next. So we're going to do server-side rendering with WooCommerce on the back end. So we have one EC2 instance now that serves the data, and we're doing server-side rendering at Lambda at Edge. So that means if someone in London, when they view our new e-commerce site, they'll be viewing it from an Edge location in London, server-side rendered to a React-related application. Someone in the Philippines will be using CloudFront's huge or Lambda Edge network to serve it from the Philippines with just the data coming from our particular from our servers. And that is a very powerful use of serverless technology. So if there are any of you guys that actually are already doing sort of server-side rendering, or you have that kind of requirement to distribute these websites globally, so you've got, at the moment you might have servers all over the world, this is a very promising technology. They are missing some of the Next.js RFC at the moment, but there are open pull requests for it, and I highly recommend you have a look at it. It does still work, but they're missing some of the latest features from Next.js at the moment. The other things that we kind of looked into, we're also working with the machine learning stuff. Now, this is where I was going to get into the cloud providers not being a binary decision. Basically, if you look at AWS, you think, right, cloud functions, they're the cheapest that you can get. Great, they are. They're actually the best in the market. The cold starts are shorter. They've got better processing power behind them. So yeah, AWS is great for cloud functions, but not always for everything. So we do a lot of image analysis. So when we actually looked at it, if you look at Amazon's offering, we would need logo detection, which is down the bottom here. We'd also need food recognition and for a few of the other technologies that we're doing. So Amazon doesn't do that. They'll tell you can do it. I mean, you can do it with SageMaker, and you can train your own models. And if you ask Amazon, they'll fling all kinds of support at you to make sure that you use their offering. But in actual fact, when we look at Google's offering, not only is it cheaper for the ML training, it actually offers a lot of features that save us a lot of time, thereby making it cheaper for us as a business. And we were very close to saying, well, actually, no, come on, we'll do what Amazon are doing. But then we did this research, and it became immediately apparent that's not the right way to do it. So again, by keeping that mobility in your microservices, but also being aware of what other cloud providers are offering, you can really kind of benefit your business by doing it that way. Video analysis and comparison. Again, Azure comes out on top for us. So that does, and Amazon will still say they do it. You can use Kinesis video streams, but by far Azure offers the best set of features for us. So we're going to be in 3 clouds within the next couple of months. Now, where I said I was going to give you a demo, I'm just keeping on the time, give you a demo of the way we structure our services. The way that all of our services start off is in this wrapper. Now, as I said, we're not writing serverless here. So what we do is we go to our Swagger definition, and this is just a really simple definition. We've got our post sign-in route. Our mock headers, that's the way we work with our app team. So we've got code that generates static responses based on what's in our Swagger. So it just means that once we agree the API contract, I build this, I deploy it, and then they can start working straight away with that, waiting for the guys, us to do the actual back-end implementation. So once we've completed that, we build this. Now, at the moment, it only builds into AWS. The Google Cloud stuff is something we're still working on. And what we end up with there is our deployment package. Now, our deployment package, if you look here, we then end up with our serverless YAML, which is an amalgamation. There's a load of stuff commented out there for the purpose of this, which is an amalgamation of all of these files, the Swagger, the resources. So, as I said, that's a very good way of doing it, simply because you're abstracting away which cloud provider you're using. And then all we have to do to swap these out, if I go into one of these functions, we go into our handler, not that one. We go into our handler. We have a load of logic here, which is AWS specific. So we've got our utils, which have our libraries in it. So all we have to do actually to migrate to Google is replace these libraries with our Google libraries, change the pattern here, and then we just simply recompile the serverless definition for the Swagger definition for Google Cloud, and we can deploy it. Realistic for us at the moment, I mean, it should be a couple of hours, but we're probably talking about a day's work, really, just until we've got all the finer details put in. I was going to talk a bit more about testing and things on AWS, but unfortunately, I think I'm running a bit low on time. So yeah, hopefully that'll give you a general idea of the way we've approached it. Right, scaling, cold starts, application flow-based warm-up. Now, cold starts get spoken about an awful lot, and I think they get spoken about more than they probably should now. I don't think they're the issue that a lot of people think they are. So, as an example, you've got an API, nobody's calling the endpoints, and then suddenly one guy comes along and he hits it, and it's inside a VPC, inside a security, a VPC with an IP address attached. You can get up to 4 seconds now. It used to be 6, but it's come down a bit. But that being said, that 4-second delay for the average user is going to be, oh, my internet's a bit broken, or it's a bit slow today. And then they're not going to notice that slowdown anymore. So really the only time cold starts can be a problem for people is where you get suddenly bursts of massive concurrent traffic, which is where you want to look at warm-up strategies, which I'll talk about in a minute. But in general, don't start warming up like 1 or 2 containers all the time. If your API is not being used, that 2, 3, 4 seconds is not, all it's going to do is cost you money. It's not going to upset anybody. Lambda fan out, for those that don't know, is when you receive two requests at the same time. Obviously, you get 2 Lambda containers. If you get 3 requests, you get 3 Lambda containers, 4, 5, 6, and it keeps going out and out and out. Now, the brilliance of Lambda is it will scale infinitely. You can put 1 million requests at Lambda at the same time if you wanted. Well, I don't say 5,000, 6,000 requests, and it will always support them. But then you've got to think, well, hold on, my database server, will that support it? Probably not. And when your DB goes down, whichever Lambda is fanning out is going to take all of your microservices down with it if they're all connected to the same DB. So be aware that one of the power of Lambda is also potentially a downfall and can cause you a lot of problems. There are strategies for restricting the fan out, which we might not get time to discuss now. But yeah, they are available and it's worth reading up. Application flow-based warm-up is an idea that has been mooted a few times in projects that I've worked on. Essentially, someone's at your sign-in screen. You know that the next screen on your app is going to be the main screen, so you can say, right, this person signed in now. Have we got a container warm for main screen? Go to the main screen. Right, most people then click on my account or click on something else. So because you know the you can then keep them endpoints warm proactively. The last bit, intelligent warm up. If you really want to geek out on it and you want to really kind of do it in the best way possible, what you can do is use traffic logs. So you know, let's say you've got a month's worth of traffic logs that tell you what endpoints are getting hit at what time and how many concurrent containers. If you run through that in an ML, or if you run that through an ML training sequence, you can then query that endpoint and say, right, how many containers do I need to keep warm? I've seen it done. Works really well some of the time. I think it's just a case of more data, but it is worth thinking about if warming the right endpoints at the right time is really important to you and you're not quite sure when those times are going to be. Right, quick one. Good, the bad, and the ugly of cloud managed services. This is what I was talking about earlier. Elasticsearch on AWS, and if anyone from AWS is here, I still love you, and I would always accept a job. Elasticsearch is a monster on AWS. I don't know a company that's used it that hasn't had problems with it, simply because if you don't oversize the instance, the JVM frequently crashes. And once they're crashed, if you try and change the size, about 50% of the time, it will completely lock up and just get stuck in provisioning, which means you need to drop down to the command line, drag all that data out of the ES instance, spin up a new one, put it all back, and then point your APIs back at the new Elasticsearch. It's a pain, and I haven't worked on a project where it's never happened. Elastic Cloud is your friend, and they offer very stable, very cheap Elastic instances. Code build and deploy, yeah, they're good, unless you really got a good reason to keep your builds inside your AWS system boundary. Use CCI Travis, Circle CI Travis, because the skills are already there on the market. It will make your hiring easier, and their Circle CI certainly is a better offering than code build and straight deploy. You can use serverless to deploy Lambda APIs, and you can use the command line to deploy everything else. Cognito, I'm just about to run out of time. Cognito is basically, it'll get thrown at a lot of people as an identity solution. With Cognito, if you add custom attributes, so attributes that aren't first name, surname, telephone number, you can't search for them. So if you want to search on custom data, it's not available via the List Users API. Federated identities are Facebook identities and Google. If you can't link them back to an original identity. So if I log in with my email and then log in with Facebook, you can't make them one identity, so not 2 users. CloudWatch logging, use Elastic Cloud. It makes it a lot easier. I've only got a couple of seconds left, but I'll just show you quickly. If you're in Kibana, which is supposed to be a logging cluster, but someone's put test data in there. This is actually coming out of CloudWatch logs. We just log in JSON format, and it means that we can search for any of the fields that we specify in our JSON. Trust me when I say this, your debugging time will go down by orders of magnitude through not using CloudWatch and using this. And last but not least, GDPR, data governance in the cloud. So if you're storing data in Europe, which a lot of us will be, that's fine. Obviously, you're not breaking any regulations, Europe or Ireland, as long as it's not leaving the EU. But then let's say your company does really well and you expand and you start getting user data in the States. Depending on local, even down to state law in the US, the information governance requirements, also the information compliance requirements are different. So it's very, very easy with cloud because it has got that massive infrastructure, that global infrastructure, it's very, very easy to break the law. So make sure that where you're interacting with users, make sure you understand the local law and implement measures to store their data where it needs to be stored. And it really does, that's such a wide subject. It really does depend on how you're doing it, but do be aware of it because the fines are very, very substantial now. And I think that's, yeah, any questions at all? I'm going to stop sharing my screen, I think, just to make it easier. Any questions?
Thanks, Mark. That was really good.
Yep. Sorry, I had to rush through that a bit, guys. I could see the time running up on me, but I can answer any questions at the end.
No problem. I saw there was a question from Raj that came in that was answered. I think James and Lee contributed towards it, Mark. But Raj has asked, is it possible to build a serverless infrastructure on-prem?
Yes, AWS do offer. I don't know if it's. To be honest, the answer is I don't know. I'll Google it while Edgar's talking. I believe that you can connect local. Have like your version of AWS Cloud in your local data center, but that's primarily offered to government military customers.
Okay.
I think, but I don't know, Raj, and I will look now, and I'll answer you again in a bit.
No probs. I believe there was another one from Paulina. Is there any tips on implementing GDPR for web apps that are cloud native and serverless?
Yes. So if you're talking about GDPR in terms of consent, then number one thing is there is no such thing as implied consent. You need permission to use the data for exactly what you'll say you're going to use it for. Now, one of the things you need to watch out for is, as your systems grow, are you violating the consent that you've already got? So the advice that I give any team, not just in serverless, is at the bottom of every one of your tickets, you need to put, does this in any way change the way that we process user data? Do we have consent for it? What technical measures have we put in place to gather if we're gathering any new data? Put that at the bottom of every ticket, and that way you should be able to stay on top of it. In terms of encrypting user data, so I can see other questions coming in. Let's go. Oh, I've got down to the bottom. In terms of encrypting it, there are a lot of ways of doing that within AWS. Key management services, KMS is your friend. Certainly if you want to do one-way encryption. It's a pretty broad subject, but yeah, if you've got any kind of more specific questions in there, I can cover some more from there.
Cool. I saw another one from James mentioning about on your pipelines, have you generally favored hosted CI/CD or provisioned your own when deploying your functions?
So I always use Circle CI Cloud. The reason being is I tried 2 times now to use Circle CI on site or on-prem, and it's a bit wobbly for the money. Their cloud services are much more resilient. Again, it depends what sort of what your reason is for doing it. I mean, most of the projects I work on use the free tier Circle CI build, and they don't even need to pay for it because they're not, unless you're doing sort of 20, 30 deployments a day, you don't really need that level. But if you do, I still reckon that the hosted is better value for money than the on-prem, certainly for Circle CI. Travis, I'm not too sure about because I haven't tried it.
Sure, no problem. I was going to say is that if there's any live questions, we can unmute people if anyone wants to raise their hands. I saw there were a couple coming through from Hussein and another one from Paulina. I think Ramandeep as well. If anyone wants to raise their hand, you can feel free. Mark, there was one here. What's the main benefit of writing CI/CD pipeline? Yes.
Well, certainly with the with the CI, the way that we do it is we will take our code into Circle CI and we actually deploy that to a test stage. So what we actually do is we deploy the serverless infrastructure into AWS, but in its own kind of stack. Because the thing is, if you're running serverless offline, it doesn't really give you that proper am I Lambda function running in AWS or am I Cloud function running in Google. So we use the CI/CD to deploy to a test stage, actually check it works in AWS, and then we deploy it to where it's supposed to be going. So it's a very useful step for really just ensuring quality, because it is very, very easy to break serverless applications if you get some of the config wrong. Just through the complexities of security groups, VPCs, IP, I mean, it can get pretty head spinning. So yeah, it's good to have that consistency.
Fantastic. Okay, cool. I think you somewhat might have answered Paulina's most recent question there. It was sort of about how do you approach testing serverless applications locally? Do you separate the AWS account under the main account or mocking? Was there any tips on that?
So there's a few ways we can do it. If you're talking about unit tests, have I got just 2 minutes to share my screen again?
I think so. I believe so, yeah.
So if we're talking about unit tests, the easy way to do it is test helpers. So with a Lambda function, typically you'll have event context callback. Yeah. So with your test helpers, the easy way to do it is you've got a generator. So you generate the event, you generate the utils, which is just basically a stubbed out version of all our helper functions. And then you can just basically pass that into your test. So if I've got an example here, no, I haven't got, this is just a shell. But yeah, so basically then you can actually you generate the handler, you generate the utils, generate the handler, generate the event, and then you can just pass that into your functions for local testing. If you're talking about full integration tests, when I do, if I do export node-env equals test, test. So the way that we've set up our serverless YAML, is that going to work? Yeah. Is you see where we've got in here current stage, yeah. So we have in each of our stages, we've got, or each of our environments, we've got sign-in key -dev, sign-in key -test. So by setting these locally and pointing it at, see, it's not finding them. See, it's got this one here. It's not finding them because I'm signed into a different AWS account. So what we do there, if we're testing locally, is by setting node-env and the stage, we're then pointing at a set of different AWS resources. And that allows us to actually test against the test environment or whatever environment we want, just from local. But yeah, it's very much about appending and naming your resources, including the stage that they're in there within, if that makes sense.
Mark, last one was from Ramandeep, who is a beginner in AWS. He was wondering if there's any, I think, services that he should focus on as a sort of junior cloud engineer.
Well, it depends what his employer does, but I mean, I think certainly serverless framework, if they're letting him use it, definitely get into that. Understanding Lambda and how Lambda works, definitely. KMS, and systems management, SSM, secrets management. That's under the systems manager, and it allows you to store secrets, which is where we're getting those guys that I was just showing you from. And that prevents you having keys in code. So you can pull those out, and in your serverless YAML, you can then specify them as environment variables. So yeah, just the basics. So what you want to try and do is kind of understand, right, I understand I do a Node API, but how do I make it as secure, as good as I've got on in Lambda? And that'd be a good place to start. And then, yeah, I guess moving on to, I definitely start by understanding pricing, because one of the misleading things about AWS is they say you can do, was it 23 a second, 1 million requests for $50 50 cents in a month. 1 million requests, yeah, that's fine if they didn't call a database server. So if they call a database server, you've then got to have a database server that can handle 1 million requests a month. So there's a cost involved in that. If they send SNS, there's a cost involved in that. SQS, you can end up with a 50-cent bill costing you 10 grand if you're not careful. So yeah, just kind of understand the pricing, which to be honest is very difficult. Don't kill yourself, but yeah, just try and get an idea on it.
Nice. Well, Ramandeep, I hope that helped with your questions as well. I hope those questions helped everyone in general. But as I said, any overflow, make sure that you get them on the chat or on Q&A or anything, and we'll make sure to pick them up. Well, yeah, again, Mark, thank you very much. Really appreciate that. I enjoyed the presentation a lot. I thought it was interesting, and I hope the wider demographic of the audience did as well.